So we're just going to look at indices. It's a pretty quick lesson. So indices are, to the power of, and how that works. So it's just a set of relationships. So we begin with a to the power of p multiplied by a to the power of q, and that's equal to a to the power of p plus q. So you'd be familiar with that, if you were to just multiply a by a, that would be a to the power of 1. So I'll just do that here. So if you have a to the power of 1 and a to the power of 1, well, that's a squared. So that follows with this relationship. So, this kind of matches with our intuition. Next, we have a to the power of p divided by a to the power of q, and we say that that is equal to a to the power of p minus q. So does that make sense? Well, imagine you had a cubed and you divided that by a squared. Well, that's going to equal a. So is that what this relationship says? Well, it's a to the power of p minus q, so this identity tells us that the answer should be a cubed minus 2, so that's equal to a. So this is equal to a to the power of 3 minus 2, which is a. So this relationship kind of makes sense. So you don't really need to learn these things. I mean, they're just pretty self-evident. I mean, but you basically want to think about it a bit to see that it makes sense to you. So there's another 4 or 5 of these, but we can zoom through them. And there's a few that are slightly odd or unusual, so are worth doing. So what about a to the power of 0? Well, we define that really. That's equal to 1. But you could have also done it just using these expressions. So I'll just put a little number here so I can refer to them. So like say you didn't know what a to the power of 0 was, but I've just told you rule 1 and rule 2. So put it here. So rule 2 says a to the power of 1 over a to the power of 1. So p is equal to 1 and q is equal to 1. That's a to the power of 1 minus 1, which is equal to a to the power of 0. So then what's a divided by a? Well, that's equal to 1. So if I didn't tell you this rule 3, but we'd accepted rule 2, well, we would have guessed, we would have said what a to the power of 0 is just using rule 2. So that's what we basically do for most of the rules. So just continuing on, since we've got a few to get through. but we're nearly halfway there. So what's a to the power of p to the power of q? Well, that's just going to be a to the power of p times q. You can think of an example just to see whether that makes sense. So say p is equal to 2. So say p is equal to 2. Then you'd have a squared, and I say cube that. So q is equal to 3. So then a squared cubed is going to be a squared times a squared times a squared. So that's going to be a to the power of 2 times 3, or a to the power of 6. And that's all that this rule number 4 is pointing out. So again, no real surprises. So I suppose I'll clean, we need some more space to do the rest, so clean this up. Rule 5. A to the power of 1 divided by q. So how would that work? Well, the answer is it's the qth root of a. So does that make sense? So rule 4 says if you have a to the power of 1 over q and I raise that to the power of q, then that's equal to a. So then that means that, so from rule 4, so then that means that a to the power of 1 over q is the qth root of a, because if a to the power of 1 over q, as in if I take the qth root of both sides, then I'll end up with a to the power of 1 over q on the left hand side and the qth root of a on the right hand side. So therefore a to the 1 over q is the qth root of a, which is all that rule number 5 is telling us. So, you know, that makes an intuitive sense. So only a few more left, and they're all pretty much along the same line. So what's a to the power of p over q? Well, that's just going to be the qth root of a to the power of p. Using the similar logic to the way we got rule 5. You know, if we just look at, do the exact same steps, so we'll just be replacing a to the power of p, or we'll be replacing a with a to the power of p. So instead of ending up with a to the 1 over q is the qth root of a, we'll end up with the qth root of a to the power of p. So nothing particularly different there. Now a slightly new thing. What is a to the power of minus p? Well, I'm just going to go back to rule 1 here. So that says a to the power of p multiplied by a to the power of q is a to the power of p plus q. That's an a. So if q is equal to minus p, then we get a to the power of p multiplied by a to the power of minus p. That's going to equal a to the power of 0. since that's p minus p, that's equal to 1. So therefore, dividing both sides by a to the power of p, I get a to the power minus p is equal to 1 divided by a to the power of p. So my a's and q's are pretty much the same, unfortunately. So I had a to the power p times a to the power minus p is equal to 1. Divide both sides by a to the power p. So I get a to the power minus p is equal to 1 over a to the power p, which is rule number 7. Only 2 more left. So what is ab to the power p? Well, that's just going to be a to the power p, b to the power p. So, you know, if you have ab, I mean ab to the power p is ab multiplied by, like that's just ab multiplied by ab multiplied by ab, you know, p times. So then if you just group all the a terms together, because, you know, if you're multiplying ab by ab, I can just move the a across. So I can move all the a's to the left hand side and all the b's to the right. And then how many a's do I have? Well, there's 1 from each of these p ab terms, so I'm going to end up with PA's and I'll end up with PB's, and that's all that this is saying, so no surprises there. And finally, we have a over b to the power p. So using exactly the same logic as what we did for rule number 8, that's just a over b multiplied by a over b multiplied by a over b p times. So then you can just group all the a terms together and you're just going to get a to the power of p, because there are p a's you're multiplying together, and then divide by the PB's which are multiplied together, so that's just going to be b to the power of p. So that's all there is. So I just wanted to chuck that into this week's lesson, since that way at least we've done it and we're that bit further ahead, and there's only 2 more little bits to do to complete the number strand, and we're well on track to do that before the Christmas holidays begin.